Let's solve a circuit using mesh analysis. Here is a circuit, and mesh analysis is nothing but the KVL, that's Kirchhoff's voltage law. In KVL, what we know, we have to assume the voltage drops, plus or minus or plus. How we assume it? When the current is flowing through a resistor or an element which is going to give a voltage drop, like a resistor, there will be a plus and a minus voltage drop. And if the current is flowing in this direction, wherever it's entering, it's a plus, and where it's leaving, it's a minus. So if the current is flowing this direction, it's entering from at this end of the at this point of the resistor, so it's a plus here and a minus in the other end. Okay. And one more thing is that before you start with your circuit analysis for each mesh, first we should assume the currents, how much current is flowing in each branch. In KCL, when we did, we assumed three different currents for three different branches, but here we're going to assume only two different currents for three different branches. Suppose if I1 current is entering here and I2 current is going here, I call this current to be I1 minus I2. Correct? No, the total current is I1 and I2 is here. Then what I can say, this current here is I1 minus I2. So that's what I'm writing. Or I can say that the total leaving current, I1 is entering, so totally leaving current should be the sum of I1, sum of these two currents should be equal to I1. So when I add these two things, it becomes I1. Okay, so that's first thing I do. I just assume the direction of the currents and the value of the currents. So it's I1 entering, so I2 if I assume here, then it will be I1 minus I2 current flowing through this branch. Okay, done. So let's start. So now for each mesh is a closed loop, so every closed loop I'm going to do. So there are two meshes here, actually three. That is one here and the other one is here, and the one more thing is the overall mesh I can see. But for now I have only two variables. I can choose any two meshes. So let's take these two meshes which usually or commonly used. Okay, so let's take one and the other one here. So when I take the first mesh here, it is like plus 12 volts. It's a minus and a plus. So plus 12 volts. And here it's a plus and a minus. So minus 2 into I1. The I1 is the current in this branch. So plus, it's a minus because it's a drop. It's ending with a minus sign. So minus I1 is 2. So 12 minus 2 times of I1. Why it's I into 2? It's because V equal to IR. So voltage drop is the resistance times the current. So 12 minus 2 times into I1. And now coming to this direction, there's 2 ohm resistor. 2 into the current flowing is I1 minus I2, and it is a drop, so it's a minus 2 I1 minus I2. And I'm coming to the same point again, so the circuit is closed. That means what? All the voltage drops are done, so you can equate it to 0. In a closed mesh or closed loop, all the voltage drop sum will be equal to 0. Yes, so mesh 1 done. Very good. Now coming to the mesh 2. In the mesh 2, I'm going to start from this point. And one more thing, you can start from any point. You can start from this point or this point or this point, anything. But if you start from this point, I have to come back to this point, complete it, and then I can equate it to 0. That is my mesh analysis says, or my KVL says, right? The sum of all the voltage drops in a circuit, closed circuit or a closed path will be equal to 0. Good, I just reminded you that. So now I'm starting from here. So current going in this direction, so plus and a minus. So what is the voltage drop? It's a resistor times the current. So minus 4 into I2, and now plus and a minus, it drop again, because it's not a drop, but if I go in this direction as a polarity of plus and a minus, so I say minus 5, and then I'm going up here, so it's a minus and a plus. Minus and a plus, it's ending with a plus, so 2 times of I1 minus I2. So that's my mesh 2 equation and equate to 0. Now what I'm supposed to do, I need to solve for I1 and I2. Have two equations, and I can just substituting one equation with another one, and this one equation, this and the equation. One equation I'm multiplying with 2. So I'm getting 10, 4. The second equation I'm multiplying with 2, and I'm getting this 10 equal to 4I1 minus 12I2. And then I'm just subtracting. I'm subtracting the equation 1 with this equation, and I get I2 equal to 0.2 amps. Similarly, if I substitute this I2 back in any of the equations here, I will get I1 equal to 3.1 amps. You can try this. You can pause the video and do this. Okay, good. And then let me say, what is I1, what is I2? I1 is a current in this 2 ohms that's traveling through 2 ohms, I1. Good. And I2 is a current that was traveling in this branch, that is across this, flowing through this 4 ohm. Very good. And what was I1 minus I2? I1 minus I2 was a current flowing through 2 ohms. So this is very important. I need to know what is the current to 2 ohms also, right? This one in the middle. So that is I1 minus I2. So I'm finding I1 minus I2 as well. What is I1 minus I2? It is 3.1, very different. Here. I1 minus I2, that is here. 0.2. So 3.1 minus 0.2 is 2.9 amps. It's a current flowing the middle one. Good. right? So we're done with this, and we did the same circuit for the KCL as well, and we can verify that we got the same I1 I2 currents, the branch currents, for the in the KCL method as well. So both the methods are going to give us the same answer, so there's no problem. Whichever you feel good or whichever you're comfortable with, you can use that technique and analyze the circuit. So thanks for watching and keep learning. And if you have any doubts or any problem in understanding my lectures, you can always post a comment. I'll be happy to respond. Thanks for watching again.